everyone, it's Ms. Stewart. Today we're going to be learning about section 2.4, which is ecological tolerance. The learning objective is going to be that you are able to describe ecological tolerance. And at the end of this activity, you'll get a chance to practice a new suggested skill, which is going to be identify an author's claim. And from the notes today, you're going to gain knowledge on learning the specifics of what ecological tolerance is and how it applies to individuals and species. So ecological range of tolerance is the range of conditions, such as temperature, salinity, pH, sunlight, things like that an organism can endure before injury or death results. Now, species and individual organisms both have a range of tolerance for all the different environmental conditions of their habitat. So it can vary on a species level, but also like an individual organism level as well. So an example of this would be with salmon. So salmon as like a general species have a basic range of tolerance for temperatures from 6 degrees to 22 degrees Celsius, which is quite a range. However, some individual salmon have adaptations that give them a range of tolerance that's even outside that basic range for the species. So if we were to look at this graph here, this is going to show us 6 different individual subspecies of salmon. And if we are looking at the x-axis here, it's talking about temperature. And then the y-axis is talking about aerobic scope, which means the amount of oxygen that they are able to intake. So if we look at each of these different ones, you can see the graph. You have multiple individuals are in each of these bars. So as a species, you can see that even like the weaver is going to have a different range of tolerance from the gates, because you see that this is shifted off. But even within this exact population, like if we were to just look at the gates, you've got a lot of them in the middle here, but you have quite a range on the lower end and on the top. And this represents different individuals in the species that have their own adaptations that give them a slightly different range than what you might see of the general average. And so as a whole, all of these are types of salmon. So salmon as a whole are going to have quite a range. Now, if we think back to what we talked about in our 2.1 Introduction to Biodiversity notes, this is due to genetic biodiversity. And this is important when we're talking about like the survival of species, because having this wider ecological range is going to make them more resistant to disturbances, which is another phenomenon that we talked about in the 2.1 notes. So an example could be like global warming. So if global warming causes the temperatures to go up in the marine environment that these salmon are living in, they are going to still have a wide range so they can actually handle a bit of a shift. So they're more resistant to disturbances. So when we're talking about ecological range of tolerance, there's kind of 3 different zones that we talk about. And the first one is going to be the optimal range. And this is the range where the organism survive, grows, and reproduces. So this is kind of where they would choose to be. If they can pick where they're going to be, it's going to be in the optimal range. Then we also have the zone of psychological stress. And this is going to be the range where organisms can survive, but they experience some stress. And sometimes it can be as extreme as like infertility or lack of growth, but sometimes it can be just like decreased activity from being in this zone of psychological stress. So if we're looking at this graph here, this is going to represent like the population of this organism where it's found. So maybe we're looking at like the range of pH and temperature. Right here in the middle is going to be the optimum range. And this is going to be where you're going to find the most number of organisms. If we're looking on this Y here, the most number are going to be in this optimum range. It's kind of their preferred niche, that habitat where they want to be. Now, we do still have organisms that can be found in the zone of psychological stress, but as we're seeing, there's going to be smaller numbers here. And some of that might due to the fact that, like, if your stress is causing you to be infertile, you're going to have less offspring, which is going to decrease the amount in that area. So this is going to be the zone of stress. We're going to find less individuals, and the optimum is when we're going to find more. Now, as you continue to go here, you hit what we call the zone of intolerance. And this is going to be the range where the organisms will die. Now, when we're talking about the zone of intolerance, we don't want to just be general and say, well, they'll die here. You want to be specific of like what is causing this death. So examples might be thermal shock from a different temperature range, or lack of food, lack of water, lack of oxygen. That is going to be specifically what leads to them dying in this zone of intolerance. Now, it has been a common FRQ type question to talk about range of tolerance. However, it is also something that you can very easily bring in to a wide range of FRQ topics on the test. So I'm going to just talk about some general writing tips for FRQs on how this ecological tolerance relates to it. But the other reason why I'm going to kind of go in depth with FRQ examples is to give you some practical examples here of the ecological range of tolerance, and then how you can actually like connect the dots of this range of tolerance without just leaving it like oh, well, they died, but to give more details in it. So on FRQs, if you are asked any question about like human activities or natural events that cause environmental disturbances, which it is highly likely this will show up on an FRQ question for you, what you can do is connect your answer to the ecological range of tolerance, if you are able to. And if possible, connect human activity to climate change. Now I'm going to show you some examples of like specifically how you might make these connections. So for example, human activities such as electricity generation, transportation, agriculture, all of those release carbon dioxide, which causes climate change and global warming. Now, the way that you would connect this to the ecological range of tolerance would be, for example, global warming warms the ocean, which shifts the temperature outside the range of tolerance for many fish species, causing die-offs. So this is going to be how it is that human activity can be tied to changes that then relate to the ecological range of tolerance. And if you want to take it a step further with the FRQ writing tips, is try to connect that shift in range of tolerance to a specific kind of physiological stress. So not just saying like they die, but some examples of this could be suffocation, thermal shock, lack of food, water, nutrients, oxygen. So continuing with that past example I just showed you, if global warming warms the ocean, this is going to shift temperature outside the range of tolerance for many fish species. Since global warming increases ocean temperature and warm water holds less oxygen, fish may suffocate due to lack of oxygen. And that will be like a full, cohesive explanation of the entire picture of how it is that human impact then leads to the dying of some species because of that ecological range of tolerance and because of the actual like physiological stress that occurs because of being outside of that range of tolerance. So those are just going to be some FRQ writing tips because this is kind of an easy one that you can use on a wide range of FRQ topics that might show up, but also because, again, this just kind of gives an example to show the step-by-step of the importance of being like outside of range of tolerance and what's happening to the organisms when that occurs. So this is another example. Sorry, I forgot that I gave two examples. And this second example would be like global warming can increase droughts. And with increased droughts, rainfall patterns may shift outside the range of tolerance for many plant species, Without enough rainfall, these species may suffer population decline as their roots are unable to absorb enough water from the soil. So again, if you are given an explain prompt, this would be like a beautiful step-by-step 3-sentence explanation. So what you're going to be doing for your practice FRQ is a new skill that we have not yet practiced. So I realize you're new to it, so do your best with it. But you are going to read through this passage, and the passage is also linked on your document where you have these practice FRQs. But you're going to read through this and you are going to identify the author's claim. Now, when you identify the author's claim, you're going to identify like a testable hypothesis type claim. So when you are looking at the claim, is this something that is testable? If so, and if it's what the author was saying, then that is going to be the author's claim. So that's what I'm going to have you do for practice FRQ with 2.4. And these were the notes on 2.4, which was ecological tolerance.